Healing with Technology, Advancing Healthcare with 3D Printing. I'm Zachary Barton. I go to Tarleton State University. It's for Engineering and Technology 3318. It's May 5th, 2018. My hypothesis is, should Children's Health Hospital implement a 3D printing laboratory? I'm going to go through my methodology, the results, a discussion of my results, and then my recommendation. My methodology, I'm going to develop an evaluation criteria. First thing is that the 3D printer needs to have a low cost for initial setup. It also needs to have the minimal training needed to be implemented. And we need to have the ability to upgrade in the future as our needs and our utilization increases. So the first thing I did was I researched the 3D printing technology. And the main thing with 3D printing is that you can customize your products, and there's to make things highly specialized and user specific. And so there's a rapid design and manufacture, because you can go straight from an STL file into a printed product. And so what would have taken weeks could take just hours or days. Machine costs are becoming very affordable as this technology is becoming older. So therefore, the buy-in from the start is going to be low. Depending on the machine that you want to get, we can get a lower end machine just to get our feet wet, and then figure out if this is something that we're really going to utilize in the future. So our in-house 3D printing laboratory versus outsourcing to a third party, because it's going to be in-house, our costs will be lower, and our turnover will be quicker. We can go straight from a scanned image from a CAT scan or MRI to the actual 3D printed model very quickly, because we're not sending it out to another company, and that company's not having to convert our MRI, our DICOM file into an STL file that the printer can use. So another thing in my methodology was to determine the most practical uses in the medical field. And custom prosthetics, organ modeling, which is taking a patient-specific scan to create a patient-specific model of their organ that we're going to operate on, so that the surgeons can really customize and go through the procedure so that they know the exact way that organ's going to look and the exact way that the tumor is going to look before they even open up the patient. And then they can also consult with the patient to show them exactly what's going to happen. Using a model says, this is exactly what it looks like inside you right now, and this is what we're going to do. We're going to take this piece off, or whatever the case may be. And also cardiac stents that are custom sized for children at our hospital, because obviously as a child grows, their organs and their veins and their arteries and all that are going to be different sizes along the different stages of their life. So therefore, really being able to take a 3D printer and customize things to the very smallest detail for our patients is going to be a greater value than even in the adult healthcare market, because a child's going to be a different size at all different stages, and our children patients are the most vulnerable. So therefore, utilizing this technology to really cut down on the procedure time and cut down on the blood loss and things are going to be a great value that our patients will see, and that our insurance providers are going to see and want to pay for to help the life of that child. So that goes under the children require that specialized planning, because like I said, the organs are going to be a different size for every child. A 2-year-old organ and a 8-year-old organ are going to be different sizes, so therefore the planning and how it's going to be used are different for each patient. And once again, our procedures performed are critical in nature. A lot of times we're operating on a child's heart or, you know, their liver or whatever, you know, and just that little bit extra planning may be the difference in that child surviving the procedure or not. So really you can see the value added in this, you know, being able to custom model their organs and be able to really plan that procedure ahead of time in a 3D way instead of just relying on 2D images like a CAT scan or an MRI scan. So this advanced surgical planning is going to allow for shorter procedure durations and less blood loss. Just like I said before, you know, there's this a study that I showed in my report, you know, where procedure times were 30% less for those that use 3D modeling for the planning of the surgery, and also the blood loss I think was, you know, 25 to 30% less in each one of those patients compared to patients that didn't get that 3D modeling technology in their surgical planning. So then I'm going to focus on a specific application. So really the greatest thing that I see value in right now for us is going to be that patient-specific 3D modeling, because it's something that we can do, and you know, there are other areas where people are using 3D modeling in the medical field, but as far as getting in there and getting used to it with our radiologists and stuff like that, then we need to do something that's not actually going into the body. It's just helping with the planning of the procedure. So that's really something that I think we can do, because we're not printing you know, biomass or anything. We're actually just printing the plastics or what have you to make a model of what it's going to be inside the patient. So it's going to allow us a lower cost versus sending those scans out to a third party and having them do it. You know, we're going to already have our radiologists able to do it right there in-house. And once they get those models to the surgeons, we're going to have lower procedure times and less blood loss, and it aligns our hospital with the leaders in the industry, just like, you know, Cook's Children already uses this technology, and all the top hospitals in America utilize this kind of technology. So we really need to jump into that arena of healthcare quality. So I determined which printer was going to best fit our needs and our budget at this moment, and it's going to be a Stratasys Uprint SE Plus. It's one of the entry-level printers, and really the reason why I chose this was, one, the buy-in price, because it starts at, you know, right under $21,000, which is going to be an easy thing for us to pass on the board. And you know, it gets us into that mode of using this 3D printing technology, so our radiologists are going to be able to learn, you know, and start to feel comfortable. And it's going to print in 9 different colors for high contrast modeling. So really, when we're talking about modeling those patient-specific organs, you know, we can show the veins in different colors, we can show the heart in a different color, we can show, you know, the arteries in different colors, or if it's the liver and the spleen and the, you know, the bladder and the kidneys can all be different colors, so that you can really pick them out. And then, you know, you put the tumor in a different color too, so you can show the patient, you know, this is the mass of the tumor that we're going to take out, and you know, this is where we're going to do our cutting and suturing and things like that. So it's really going to have a benefit of being able to print those different colors at the same time. And then it allows for an 8" by 8" by 6" model size, and that's that's limited by the envelope and the size of the machine. But you know, even bigger things that we can print can be done. You know, we can section it off, but you know, that's the kind of size you're going to get with a printer of this budget at this time. You know, the bigger printers are going to be into the hundreds of thousands of dollars, and at this moment I don't think that that's something that we need to push. We need to get used to the technology and get it in the door and start using it, and then we can start justifying, you know, the bigger machines. And so in all, this machine allows for immediate implementation at a low cost, which is really one of the criteria that we're looking at the very beginning of this presentation. And then it's got user-friendly software that comes with it. So there's another criteria that we're going to satisfy from the beginning. And then there are more capable printers can be purchased later as our utilization and application increase, just like I talked about before. Is once we get these in the door and our radiologists start feeling comfortable with them and utilizing them, then it's something, that we can go to our board of directors and say, listen, this is really starting to be something that we're doing, and it's helping our patients, and then we can get that more funding in order to get a bigger printer or more technicians or more, this is our starting point. So in the future, we can have options as going forward. And then those printers that we're going to get in the future are going to use the same software. If we stay with the Stratasys brand, sorry, excuse me, then we're going to be able to use that same software and we'll feel comfortable with it. So my results were, is the printer cost effective? Yes. $21,000 starting price. Is the printer user friendly? Yes, there's included software, has a short learning curve, and then the technology is interesting and fun. So I really think that once our radiologists get into this, they're going to have that initiative to really learn and want to learn it, and the more they learn, and they'll find new things and faster ways to do the conversions on the files, and to clean up the STL files so that you get a clean, nice print. And then will the hospital be able to upgrade? So this is another criteria. As our needs grow, then more capable machines can be purchased. As the utilization increases, the benefits increase as well. So, once we've used it and get used to it and start really going to this printer every time, to make these models, because we've seen that it helps our patients. Like I said before, then we can justify getting a more expensive machine in the future. So in closing, I recommend that Children's Health Hospital purchase a Stratasys Uprint SE Plus and train the radiologists that are already employed there to use it. I feel that the benefits seen from this purchase will far outweigh the costs of implementation. I also feel that the hospital will realize the great potential for a fully functional 3D printing laboratory in the future once the initial machine is being used to provide improved health care for our patients. Thank you.